Hello everyone, I'm Ravi Verma, co-founder and CTO of IMESH. Today we'll be discussing about Istio Ambient mesh, which is a new data plane. We'll be knowing more about it in today's session. So let's go ahead. Today's agenda is what is Istio Ambient mesh. We'll be seeing like what all the things it is bringing with that. After that, we'll go through architecture of ambient mesh. And then next we'll be deploying it to Kubernetes cluster. We'll be deploying a sample application and we'll check like what all the functionality it is providing. So few of the functionality we'll be covering today. Other functionality we'll be covering in subsequent sessions in future. So first, what is Istio Ambient Mesh? So as we know, ambient mesh and Istio for that matter. So that Istio is a service mesh we know, and the default Istio service mesh it works on a sidecar ways that we'll be covering that in a with detail in the next slide. So coming to ambient mesh, it is a new data plane for Istio, which is having no sidecar. Like in the default Istio, we know it is having like sidecars. A sidecar is kind of a proxy, which is based on Envoy, and it is attached to each of the pods basically. So what it is bringing that ambient mesh, simplified operations, reduced infrastructure cost because we don't have sidecars now, and that the cost of memory, CPU, and all utilization of each sidecars now it will be reduced because it is having no sidecars. So that is a high level intro to ambient mesh. We'll be covering in more detail in subsequent slides. So this is the Istio default architecture in which we can see we have a service A and service B, for example. All of the services will have their own proxy, which is based on the Envoy. So Envoy proxy, which is also called a sidecar, and all of them will be talking through mTLS. Like there'll be the channel is secure through mTLS, and each and every services will have their own proxy in their corresponding pod. So that we can see. So this is our currently default Istio architecture. So this is the way it works. Now coming to the new one, like ambient mesh, what it is bringing. So here we can see service A, service B running on node 1, for example, service B, service C is running on node 2. And those node, they are talking to a secure channel. So this is also called H-bone communication here, which is HTTP based overlay network environment, basically. So it is a next generation transport channel or transport communication, we can say. So in which what in this case, what happens, Gtunnel or Ztunnel, we can say, it establishes a secure channel between all the nodes basically. So suppose we have only two nodes, so these two nodes they'll be talking over a secure channel. So if service A wants to communicate to service C, so what happens, service A sends a data and that data goes to Ztunnel on the node node 1, and that transfer the data to Ztunnel on node 2, and after that the data is transmitted to or transferred to service C. So here Ztunnel is daemon set. So what that mean is it runs on each node basically. So each node will have one instance of a Ztunnel, so that the secure communication can be established between or among all the nodes. So that's a part of the Ztunnel. Ztunnel provides L7 like transport layer security basically. So this communication can be secured. And yeah, one more thing here. So even if service A wants to communicate to service B, it goes through the Ztunnel and Ztunnel transfer the data to service B. So even if they are on the same node. But yeah, so it takes a fast route rather than like establishing a whole full-fledged network communication. It takes a fast route and it transfer the data from here to here. So now we have, what about L7 processing? As we just discussed, like Ztunnel provides L4 level processing and routing basically. If we have a requirement for L7, so we need a L7 level proxy, which understands L7 protocol and does the routing or all the parsing or and all other things which can be done at the level 7. So for that, what happens? We deploy a Waypoint proxy. So that Waypoint proxy is based on Envoy. And in that case, when we deploy Waypoint proxy, what happens? The data, if suppose, for example, service A wants to communicate to service C, that time it will A will send the data, so it will go to Ztunnel. Ztunnel will send the data to Waypoint proxy C, and that Waypoint proxy C will send the data, like after processing the data which need to be processed, will send to Ztunnel on the another node, and after that the data is transferred to service C. So that way it is established. So similarly, if C wants to communicate to B, C will send the data to Ztunnel on the same node. Then that Ztunnel will communicate and send the data to Waypoint proxy B. And after that, data will come from Waypoint to Ztunnel of node 1, and then it will go to service B. So here we have one thing to note is like Waypoint proxies are deployed as a pod, basically. So they are also a workload. So not necessarily these pods will be running on the same node for which a data request is coming. So for example, that Waypoint proxy, if it is running at node 1, so what will happen? So that C will send the data and it will go to Waypoint proxy on node B, and that send data directly to on the same node. But what happens if the Waypoint proxy node is running on node 2? So in that case, what will happen? That similar thing will happen, but the thing is, it will first go to Ztunnel. Ztunnel will send the data to Waypoint proxy on the same node, and after that, the data will be transferred to node 1 and then service B. So it's not necessarily that Waypoint proxy will be always sitting on the same node on which a particular service is getting serviced. So there could be possibilities like we have a increasing load. In that case, what we can do, we can deploy multiple Waypoint proxies to cater that request, basically, as it is a kind of a pod which can be scaled based on our need. So that's one of the biggest advantage here in case of Waypoint proxy and ambient mesh. So we can scale as much as we want. Plus, it is bringing, as we can see, it is reducing the proxy. Like initially, it was having one sidecar attached to each of the services. Even if we don't need that L7 processing, still we had to put it inside each and every pod. But in this case, if we don't want L7 processing, it is not required. So only level 4 processing or level security will be achieved through Ztunnel. So that's the biggest advantage ambient mesh is bringing to us in a kind of microservices now we'll have, and the infrastructure cost will bring down drastically with this. Now coming to demo. So we'll be installing ambient mesh into we'll be installing into GKE, like Google Cloud Platform. But before going directly to installation, there is quick note that we need to know. Currently, that ambient mesh, as we know, it is in alpha and active development is going on. So few features or the behavior might not work as expected. Sometimes it might behave differently. Like if you deploy, there could be possibilities like communication is dropping some time in between, or after the deployment, if the ambient mesh is already enabled, and if you're deploying a new microservices into the same namespace, there could be possibilities like ambient mesh is not working. So those are the stabilities things which will be fixed in the future. And few of the features still it is in active development. So we might expect few of the things not working, few of the things it is behaving differently, and few of the things whatever it has been developed so far, maybe it might change in the future, because based on the testing, based on the performance, all those things can be changed. So for now, so one thing to note is currently ambient mesh is not working with Calico CNI. So that is with Google Cloud as well and Azure Cloud as well. For AWS, we'll be sharing that details in the future session. So what we need to do, so one thing, if we want to try it to be installed and working in a cluster, real cluster like Google or Azure, I'll be showing what we need to make sure to make it work, to at least to test it on the cluster. Because currently that CNI, Calico CNI is not compatible with the ambient mesh implementation. So for Google, what we need to do, when if we create a cluster, we can come here. In case of networking, we need to make sure we are not checking this one. So data plane V2 also it's not working currently. In future, it will be working because it's still in development. And with Calico, ideally it is expected to work with Calico network policy and all, but currently it's not working. So we need to make sure while creating the cluster, these two are unchecked. Otherwise it will not work. So this is the case of GKE. The similar thing need to be considered for Azure as well. So in case of Azure, what we can see here, we need to make sure we are selecting here Azure CNI, and here we need to select none. Then only it will work. Otherwise, it will not work. The current release, it's not working. It's not compatible with this currently. So that will be fixed in the future session, future releases. Okay, so let's go ahead and start the deployment. So what we can do, let me bring my terminal. Yeah. So here for that, as I have mentioned, this is the link. We need to go and download the alpha release. So let's go there and check what it is giving. So here we need to download the alpha one basically. So this is having ambient mesh implementation. We need to download this package. So we can go here and download Istio based on our platform, like either Windows or the Linux. So mine is Windows. Currently, I have already installed it, and it is available in this folder. So we can see the content. I have already extracted it. We have been, so istio.ctl will be there here, and we have manifest files and samples that we'll be using today to deploy. So let's go ahead and deploy it. So let's check istio.ctl. It is not added, so let's go and add to the path. So just let me do it. 1 minute, I'll copy this. I need to set the path, so I'll set it. It is in bin, and then I'll add path. Now we can check istio.ctl version. So we have this the release number 1.18.0 alpha 0. no Istio is installed in, like currently we don't have any Istio installed, so we can check that as well. So kubectl get ns. So we have a default installation like of the cluster when we create it. We don't have anything extra, even the pods and all, we don't have any workload. So that all those things will be saving in today's session. kubectl get pods, all clean. So for that, what we need to do to install it in ambient mesh mode, we need to run istio ctl install --set profile is equal to ambient. Sorry, istio ctl. Here, install. This will take around 30 seconds to 1 minute to install. It installs istiod, Istio core, CNI, Ingress gateway, Ztunnel, all those things it will be installing. And after that, we will be able to use it. So let's wait for a few seconds. It will not take much time. Then we can verify the installation. And after that, we can go for our deployment. We'll create few applications, we'll deploy it to test it. So we'll be writing our deployments here because I'll not be using book info one, which we can directly deploy and test it, but I'll be using and creating a new applications, basically new deployments and all, to cover all the components involved, so that we can know and we can see what all the things are getting involved in all the deployments, and whenever you are using the deployments for Istio, basically, and for the applications as well. So for that, we'll be creating new applications, all the required manifests, so that we can cover in a bit detail. Okay, so it is installed. We can verify that. So what we can do kubectl. So it will be installed in kubectl, basically Istio system namespace. So kubectl get nsfc. We should be having Istio system now, and we can verify pods and services in Istio system. Istio system. So we can see here we have Ingress controller, we have HTOD, Ztunnel. So basically, as I was mentioning, it is a daemon set basically. So it will be running on both the nodes. So we can verify that as well. So with O wide option, we can verify that it is running on both the nodes here. We can see, so we have different nodes, and it is coming from the daemon set. That also we can check. So what we can do, get daemon set. So we can see here. So Ztunnel was coming from daemon set. There is one more component, CNI, that Istio CNI, which I was telling, that is installed in Cube system in case of GKE. So let's verify that as well. kubectl get pods and Cube system. So here we can verify we have Istio CNI also coming. So it is again, it is for both the nodes. That also daemon set. So that also we can verify. So we can see here we have Istio CNI daemon set. So we have Ztunnel per node and Istio CNI per node. So that we already verified. And now everything is working. So what we can do, we can go ahead and start writing our application. So let's go ahead and create our first application. Let me create a folder here so that we can keep all our manifests here. And later we'll be putting this one in our repo in GitHub. So anyone can refer at any point of time. So if you feel to look into it, just look and go and look into that repo. That the link will be shared in the description. So let's create demo manifests. Fine. So let's create our first manifest. So let's name it as maybe test or demo deployment 1.yml. Fine. So let's create it. API version. We have apps v1 and deployment. Then we'll have metadata. Here we can give any name for today's. Let's give, I'll be using eco server image. So let's give a name like that. Eco server deployment 1, for example, and then let's give a namespace. If we want to keep it in a default, we can keep it everything in a default. If we want to do it in another namespace, we can do that as that one as well. So let's do it in another namespace that I will be showing as well. So namespace, we can suppose we can give ambient. And let's give some labels to this guy. Sorry. Maybe app eco server DEPL 1 we can give same, not an issue. Or if you want to keep it different, we can keep it different also, not an issue. Now we'll have spec. So let's create 2 replicas so that we can verify few things. Selector. We need to have match labels. Let's give some name, app, for maybe eco server app, eco server app 1. We can give it, and after that we can write template. So here we'll have a metadata. In which we'll be applying the same labels. So let's copy it from here, just paste it. And we'll have a spec for our pod, basically. So here we'll be having container. Let's give name echo server app 1 fine. Doesn't matter, any name we can give. Image, we can take it from IMESH AI echo server. Ports, we need to specify. So currently it is running on port 80. So we need to write container port 80. We'll be using one by default. We know we have service account associated with each pod basically. So for that, we'll be creating a new service account and we'll attach here because we'll be needing that in next a couple of uh, after a couple of minutes basically. So let's create a service account as well, and we'll attach that service account here. That will be used basically when we start implementing Waypoint. So we'll know that. No need to worry for now. Just let's go and create. So demo service account 1.yaml. E version we can give even. So even it's kind service account. Then we have metadata in which we need to give name. So let's give echo service count 1, and we'll have labels. Let's give some labels. Account echo 1. Yeah, that's it for namespace. Okay, namespace we have already given here. So let me have that as well. Okay, so let's go and create first this namespace. So for that, we can simply go here. We can write cube ctl create namespace and name ambient. Yeah, namespace created. We'll be deploying all our manifest or config files. So they are in that particular namespace. Okay, so we have deployment ready. Now let's go and create a service for this. For that, let's go and create files. So write demo service 1.yaml. For that, a version v1 kind service metadata name we can give echo server service 1 namespace ambient. Fine, we can specify spec. So selector, we need to give it selector. So we have already mentioned that one here in our. So here we need to just copy. Let's copy that and use it to avoid any typo mistake. And after that, we need to specify ports. So ports, we need to give which port it is listening. So port 80, and target port is on which pod is listening. For that also, we are keeping 80 default port. So this is ready for first application. We'll be creating one more set of applications so that we can demonstrate two different paths. So let's go ahead and create these two again. So let me copy all three. Okay, 1 minute before going there. Service account we have already created, so that let's attach to a deployment here basically. So here we need to give service account name. Now we can create a copy of all this one more. So let's go ahead and create it. So this is service account one. Let's edit it. Make it 2. Change here. To this also, let's rename it so that does not collide. This is done. Now coming to deployment. We have 2. Let's change it to all the places. Fine. We are ready for the deployment. So application we can deploy. So for that, as we know, we are mentioning service name account in our deployment. So for that, we need to deploy our service account first. So let's go ahead and deploy. So kubectl demo. We have, so let's deploy a service account first. Kubectl, sorry, apply. Should be coding error, metadata labels. Okay, let's check what's the issue with that. Service account, go name space. Oh, sorry, typo again. It's done. Let's deploy the second one as well. Now let's go ahead and deploy our deployment. Okay, again, typo labels. So let's go ahead and fix it. Labels. Yeah, here. Fine. So let's go ahead, deploy it. Second one also done. Now let's deploy our service. So kubectl demo service 1 and service 2. Let's verify kubectl get pods ambient. all four, it's working. We have created 2 replicas for each deployment. So we can see we have 4 pods running. We can verify our service. Yeah, both services are up. So now the backend is ready. Now we will configure to basically to access this from outside. We need to deploy a gateway. Basically, Ingress controller will deploy. Ingress controller will be using Istio controllers like Istio Ingress gateway. We'll deploy it so that this application can be accessed from the outside. So for that, let's go and create Istio gateway for that. So let's go ahead and create it. So let's name it demo gateway.yaml. For that, we need to give API version. Currently, we are using for this Istio based gateway. So we'll be using Istio provided CRDs and basically the definitions to define our gateways. Networking istio.io v1 alpha. So currently latest is alpha 3 at the time of like today. We'll use that kind gateway metadata. We can give any names, maybe echo. Let's give echo server gateway. Name is space ambient. Now we need to specify spec. Here we need to have selector. Here we'll be providing Istio as Istio is currently, we are using Istio based Ingress controller. So we are mentioning that only here. So Istio Ingress gateway. Servers port we need to mention. And then number on which it is listening. So 80. Name we can give anything. HTTP, let's give. Protocol. All we can mention HTTP. Then we have hosts for what all the hosts is listening. So let's put it to star for now so that we can request from anywhere like local or any place for that matter. So this is gateway we created. Now we need to create virtual service so that we can link the request. Like when we get a request, that can be forwarded to our backend. So let's go ahead and create that as well. Okay, so let's name it demo virtual service. A version networking, again we are using Istio. So alpha 3 kind, it's virtual service. Metadata name echo server virtual service. Let's give a name. Any name is fine. then namespace ambient. Then we need to specify spec. Okay, so here we need to specify a few things. So hosts again, and here we again specify same star so that we can get a request from all the places. When we need to specify gateway, so here we need to specify the gateway. So for which we just created the gateway, the name of that. We need to give it here. Just copy and paste it. After that, we can define our rules and basically path rules and all. So HTTP, for that, let's create a rule. So match. So when it is matching with this, we can specify URI and the type basically. So for exact, so it means when we are writing exact, it means that path in the URL, it should match exactly with this from the root. So we'll write, suppose, echo 1. And then we can add our route in which we need to specify destination. No need to worry about all those things. Whatever we are writing, we'll be covering this in more detail in future sessions. So nothing to worry. So host, we need to specify, like now we are specifying the backend, who is the backend. So service name we'll be giving here. So for that, let's give and go to service, our service, and pick the name. Specify in host, then port, which port we want, number 80 as it is listening on 80. So we need to specify the same. Now let's create another path, basically match rule. So match again, and again similar structure. Let me copy and paste it. To save some time. So here we can change it to 2, and here we can redirect to our second. Yeah, with this, if we deploy, we should be able to access our application from outside, like from browser. So let's go ahead and deploy it. So what all we created? We created virtual service, we created gateway, these two we created. So let's go ahead and deploy it so that we can use it. So first we need to deploy our gateway. kubectl by nf. Fine. And after that, we can virtual service we can deploy. Fine. Perfect. Let's query the IP, which IP it is. So for that, Istio, not Istio, kubectl get service Istio system. So this is a load balancer. We need to take this IP. Basically, this is IP which is exposed for outside access. So we can go ahead and just use it. On the root path, nothing is there. We have something in echo 1 and echo 2. Let's go ahead and test it. Perfect. So this request is coming from echo 1. So the first deployment. The second one is coming from the second deployment. So both are having two pods running basically, and that we can verify. So this one will change if we refresh it multiple times, we can verify. So here we are changing, it is changing here. So basically, which particular pod serve that request, that we can see here. Same thing is here. Fine, we can verify it's changing also here. And the same thing we can verify even from the terminal. So for what we did, we deployed application, we used Ingress controller of Istio, and we are able to access our application. Now it's time to add this to our ambient mesh, basically. So to introduce ambient mesh in this one and see if it is still working with that or not. So for that, we need to simply apply a label to the namespace. Currently, all those things we saw, what all the things we deployed, it's running under ambient namespace. So we need to label that one so that after that, it is basically all those Gtunnel and all the communication now it goes through the Gtunnel. So to understand that also, if it is really going through Gtunnel or not, let's go ahead and log into, like, basically to try to see the logs of the Ztunnel so that we'll understand more on it better, like whether it's really going through that or not. So let's go ahead and check it. So we have two nodes. So to Ztunnel, I'll be logging with both. So kubectl get pods, some Istio system. So I'm logging, basically I'm getting log kubectl. Let's follow it, like it will be holding the terminal. We'll be able to see the real-time logs here directly, which is coming. Istio system. And I'll copy another one for the next terminal. So let's start it. kubectl logs nf or name namespace Istio system. So we can see here currently no communication is happening or no communication is going through, or let's refresh it to make sure. So I'm refreshing it here, and let me duplicate it, and I am even refreshing the two. But still, if we see, we are not getting anything, any extra communication logs here. Nothing came. So whatever was initial thing, it was that. So now we need to just go ahead and label it, and after that we should be seeing some logs here whenever we hit the request. So for that, let's go and label it so that it is part of the ambient now. So for that, kubectl label namespace. So that namespace name we need to give. We have ambient, and we need to label with istio.io/data plane mode is equal to ambient. Okay, so to make it more interesting, what we can do, let's check a log of CNI as well. So there we see, so as soon as we apply the label, we'll be seeing like new routes are getting added for basically to create a tunnel for all the applications, and the routes and all will be created, and all the pods basically will be added to the ambient, so that we'll know as well, like, okay, now it is part of the ambient as well. So for that, kubectl get pods mission kube system. So let's log one of the pod. Basically, the similar log will be there for both. So if anyone, if you are seeing it, it is fine. kubectl. So we have excluded. Currently, we can see ambient. This one is excluded because it's the only control. So currently, it's not part of basically ambient namespace. Ambient is disabled from ambient mesh. So ambient namespace is currently not included in that. So once we enable it, kubectl, oops, see, missing. It should be added. So let's go ahead and check that log. So now we can see namespace ambient is enabled in ambient mesh, and we can see all the ports, whatever it had. Now it is added, and routing and all it's created. So we can see now it's part of the ambient. Now let's go and start refreshing the page, and still we see if it is working or not. Yes, it's working. We are able to get the request response. It's working both for second one as well. Now let's go ahead and verify. So now we can see here, we have this service account, which is connected to this one. So we can see now it is doing some communication here. We can verify that here also. So we can verify like now it is part of the ambient and it is working as well. One more thing we can do, even like one of the pod we can enter into and we can send a request to another one as well. So, okay, let's go ahead and do that as well to understand more. kubectl get pods ambient. Sorry, I think name ambient. So let's go ahead and maybe I'll enter into deployment to first pod. So kubectl exec. Sorry, need to specify the namespace. Fine. So we got the terminal. Let's go and check the service name which we had created. So because we'll be querying through that, kubectl get service ambient. Okay. So I logged into one of the pod for service. Basically, the second deployment will be sending a request to first and second both, and we'll see the log how it is behaving. So let's go ahead and curl it basically. We are getting the response from both. Okay, let's go and check. Here we can see we have a new entries as now we can see. So we have H-bone communication. So which we were discussing some time back, like both G tunnels are a secure overlay HTTP connect tunnel is created. So that is happening. That communication here we can see that is happening, and this log proves that. So basically these two difference, which I was even mentioning when I was explaining the diagram. So this one, whenever we see like local fast path, it is basically the request is going to the same like a pod or the workload on the same node. And when it is coming from the other node, it is going to the tunnel. So that log we can see here, we can verify. So that we can try, and we can We can have a look on that as well. So two, so both pods we can see as it is not running, like both pods are not running on the same node, so that we can verify. Sorry, pod. So we can see here, like for first deployment also it's running on one on both nodes. Here also it's running both on node. So whenever I'm sending one request, so one time it is going there and the other time it's going there. So that's why we saw here log both, like hbone and fast path basically. So whenever it is entering into the same node, then it is local fast path. Otherwise it is hbone. So this proves, and we have already verified that also, like it is part of the ambient mesh and it is going through the Ztunnel. But did we know, or do we know, like whether that Ztunnel, whatever it was getting created, it was mTLS enabled, like the data communication, whatever it was happening between the two nodes, whether it was secured or not? That we didn't check it yet. So let's go ahead and check it that as well. So for that, we'll be capturing few packets and we'll verify that, like if it is TLS or plain text, it's communicating. So similar kind of request we'll be sending from here and even from the browser, and we'll verify that. So let's go ahead. To do that, we need to log in into one of the, basically one of the node. So let's go ahead and enter into one of the node. So for that, I need to go to compute engine, VM instances. Let's enter into one of the node. So we'll be basically dumping the TCP packets, and after that we'll analyze, like after sending the request and all, we'll see like if it's the communication between the two nodes are happening through secure channel or not. Here. Okay, so we have, let's go. If config, let's check whether it's installed or not. Okay, so we have lot many interfaces. So this is the interface ENS4, which is connected, like which is the interface which will connect to another node basically. So the data will pass through this interface. So we'll capture the data on this particular interface to verify whether our communication is secure or not. So let's go ahead and fire the command. So it is sudo tcp dump I. So basically I for interface, so here we are mentioning the interface ENS4, we saw that. And for which port we want to capture the packet, so that we can specify. So let's say 9080 or port 15008. So basically this 15008 port is used for hbone communication, or basically hbone communication, secure communication basically. So if we are getting some data here, it means it is going through hbone. That is first thing. And second thing, we'll verify the packet also, whether it is plain text or it is TLS encrypted and all. So let's write that data into one of the files. So we can write maybe node 1.pcap. We'll download this one and we'll verify in varcirc. So let's go ahead. So it's now started capturing the data on our interface ENS4. Let's fire some request from the browser as well as from the terminal. So let's hit something. Here also, let's set removing this one. Yeah. And now even go and hit some request from terminal as well to both services and see what is happening. Fine. I think we should have some data already. Yes, it captured 220 packets with these two ports basically. So if any one of the port it was mentioned in the packet was either destination or source, any one of them, it will have that. So now let's go and download it. So let me check what's the directory I am in. So let's copy this one. Copy, and I have given already node 1 pcap. Fine. Let's go ahead, download it. Node 1.pcap. Okay, some issue. Let's try again. Just hold on. Let it, yeah, done. Let me try again. Node 1.pcap. Yeah, it's downloading. Done. Let's open it. Fine. So these are the data we can see. So let's verify a few of the thing. So we can see here destination port 15008. As I was mentioning, this is H-bone, like H-bone communication or the Ztunnel communication. It's happening on this one basically, and we can verify it is TLS 1.3. It is already using. So all the communication. So we should be seeing the application data that should follow. So this is the initial handshake and on all it happens in case of any TLS communication. So that is happening. We can see client hello, server hello, and all those cipher exchange is happening. So basically the handshake is now happening till here. And after that application data is getting started. So we can see that all the application data, it's TLS encrypted. TLS 1.3 is getting used here. We can see that. So this is the ACK that we need to vary. So acknowledgement for the data, the packet data, whatever it was getting transmitted. So we need to verify all the application data, it's TLS. So it is, yes, it is TLS encrypted. It means when we enabled the Ztunnel, automatically we got access to mTLS between those two nodes, and we can verify that also here. We can clearly see all the data are encrypted. Fine, that's nice. Let me come out of this guy. Now coming to our agenda, let's see what all the things we covered. So we did deployment, we installed Ambient Mesh, we enabled it, the Ztunnel TLS verification we did. Now we are left with authorization, L4 and L7 authorization. We'll be testing that as well. So for that, let's go ahead and create that file basically. So we need to create our basically deployment, like one of the config file again. So to achieve that. So that authorization, basically we can restrict which pod or which service can communicate to which pod and which service basically. So that it is not exposed to a kind of complete world or all or everyone in the cluster who can talk to, like for if we are processing or if an application is processing something sensitive and all, ideally or in the best practice is that we should restrict that communication. Whoever is intended to talk to a particular service, that only guy talks to that. So it is a best practice, security practice that need to be maintained. So let's go ahead and create our basically our deployment. Our L7 authorization will first start with L4 and after that we'll go for L7 authorization. So for that, let's go and create our first deployment, like authorization deployment basically. So let's name it as L4 or I'll give it only name demo authorization L4.yaml. Fine. So let's go and create API. We need to create it as this part. It is part of the security. So security.istio.io again v1 beta1 kind. It is authorization policy. We have metadata. We can give a name. So let's give echo server policy, or let's name it L4 policy. Or let's keep it policy only, not an issue, because we'll be updating this. And namespace, we can give ambient. Let's specify specification here. So we need to give selector. Okay, so let's go to terminal, view background. So here we have connected to one of the port on deployment 2. So let's apply that authorization policy on the deployment for the deployment 1, so that we can test it few things from here from the terminal, like it is not allowing or allowing all those things. So let's go ahead. So selector is like one of port selectors, whatever we had that need to be mentioned here so that it can apply on that. So it is match labels, and we need to specify a port. So basically the deployment, let's go ahead and take this one. So with this, it will apply that, and we need to have what we want to have is what action we want to have. So action we can mention whether allow or deny. So let's allow for a particular rules. We'll specify that. So rules. So here we are allowing, like mentioning from whom we want to allow or from whom we don't want to allow, something like that. That like if we put deny here, like whatever we mention below, it will be denied for that. If we allow, like whatever we are going to mention below, it will be allowed for them, and all others will be denied. So from, then we need to give source. So here we are specifying principle, like which all service accounts we are allowing so that they can communicate. So for that, principles. So it's an array kind of thing. We can mention as many as we want. For now, we'll be adding Ingress, Istio Ingress, so that whenever we are hitting a request from the browser, that request is coming, it should be allowed from here. And if something it is getting fired like from the terminal and all, that is not allowed. That will verify also, and we'll test whether it is working for that or not. Okay. So let's apply for our Ingress controller to be allowed. So cluster dot local namespace ns Istio system service account, which service account is allowed. So Istio Ingress gateway dot service dot account. Fine. So once we deploy this one, our L4 authorization basically policy will be enabled, and we should be getting, or basically we should be getting the request served if we fire the request from the browser, if we are sending, or whoever is having this service account, if it is coming from anyone else, it should not work ideally. So let's go ahead and deploy this. Okay, this one we have already verified, so I'm just closing few windows. kubectl. Something is wrong. Authorization. Resource mapping not found. The name eco server policy. Let's check what's wrong. Authorization policy security. Okay. See, small typos are causing issues. Fine. So the policy is applied. Let's go to browser and verify first if we are able to access. So we applied the policy for eco, like service one. So eco we should be able to access from here. Yeah, it's working. Anyway, this guy has like no policy applied currently, so it should work anyway. Here it is working. So from the browser, that request is going to Ingress controller. Ingress controller is sending the request, and we have allowed that one, so it's working. Now let's try with the terminal, like from the other guy who is trying to communicate, if it is able to access or not. 2, it should work. Yes, it's working. Now let's go and try 1. So it should not work because we allowed only Ingress controller to work, and this guy is not that, like not that service list. Basically, it's not having that account or the service account matching. So that's why the request is denied. So we saw, like, we applied this rule and only this guy had been allowed, all others are denied. So we can see here it is like not allowing that. And even if we follow deny here, then even we will not be able to access from the browser as well. So that we can verify as well. Deny. Let's go ahead and deploy it. It gives some warning. That is fine. Eco server policy. Yeah, so denied. We can see here from the browser as well. So let's revert it back so that we can perform the next action, which is L7 authorization. Now, once it is configured, we can go ahead and it should be working. Perfect. Okay, so now coming to part of L7 authorization. So like we saw till as we have not deployed any waypoint and we know Ztunnel only works till L4, we cannot apply any L7 policy at this point of time because we don't have anyone to process that request. So for that, we will be deploying a waypoint proxy and we will be doing some authorization at that level because waypoint proxy is capable of doing L7 processing. So let's go ahead and deploy a waypoint proxy for one of the service, like this eco service one only will target. And we will verify whether it is able to do that or not. So for that, we need to create a waypoint proxy, and that waypoint proxy can be deployed or basically can be configured using Kubernetes gateway API. So gateway. So we need to create a gateway using Kubernetes gateway API, and we need to specify few things like for which particular pod or basically which service you want to activate that so that it can work for that. So let's go ahead and create that. But to make it work by default, like all currently, at least as of now, by default, this Kubernetes Gateway API CRDs will not be installed on any cloud provider. So we need to install it. So for that, we need to run one command so that basically we need to apply that CRD. So we can verify that if it is having that or not. But if it is not, then we can simply write this command and it will apply. So kubectl customize, or otherwise we can download as well. So download and apply directly that CRD. So let's use customize to apply that, or to basically download that first and after that we'll apply that. So let's do customize. So we need to give a link, github.com/Kubernetes SIG. Gateway API and config like which version we want. So we can give our current version, which is 0.6.1. So CRD reference we need to give is equal to version 0.6.1. And let's capture it in one of the file. So let's name it gateway API.yaml. Basically, it will create a file. We can verify that, not an issue. That need to be applied. So let's go ahead and check it, that file. So we can see. So basically, the version is 0.6.1, and these are the long list of CRD. So it will be using like we'll be using gateway of gateway API type to deploy our waypoint proxy. So let's go ahead and deploy this kubectl apply -f gateway API. Sorry. So this is done. Now we need to create basically a kind of gateway of this type of from the Kubernetes gateway API CRD so that we can deploy our waypoint proxy. So let's go ahead and create it. I'll be creating here only new file. Let's name it as demo waypoint 1.yaml. Okay, and API version. We need to give other like gateway networking, not the Istio one, because it is different than that. So gateway dot networking dot gets.io v1 beta 1. It's kind gateway metadata. We can give a name, basically anything. So name, let's give eco server gty or get gtw1. Now let's give a namespace. Namespace ambient. And we need to apply annotations for which service account we want to apply this waypoint. Basically, for which workload we want to apply this one. So for that, we need to use annotation, basically annotations. And in that, we'll be mentioning like for which basically, so which service account. So istio.io for service account. And we need to put that name. So we have created one service account at the beginning that I mentioned we'll be using later. So this is the one. So we need to take this guy name and put it here. So that it means this will be applicable for that particular service account, and that particular service account was linked to the deployment of those two parts. So whenever we have any request, it will be coming, or basically it will be going through this waypoint proxy. So now let's go and add specification for this. Gateway class name, like who is implementing this one. So we'll be giving it is Istio Waypoint. It's the basically controller of or the implementer of this, who understands this whatever we are writing here in the specification. So listeners, we need to give. So if you remember, we had one API gateway session. In that one, we were writing similar kind of thing. So as it is based on that gateway API specification, so it will look like same. And this nurse, fine. And ER is fine, yeah. Allowed routes. We need to give namespace. No need to worry all about this. We'll be covering this one, these things in more detail in future sessions. So no need to worry about all the configurations, whatever we are writing here. But yeah, there's a kind of giving the understanding how it works from. Same name, we can give anything. Let's give IMESH or IMESH AI.ai. port we need to give. So as we know, and as we had seen in our initial discussion, like when we introduced Waypoint proxy, it was coming in between the Ztunnel. So basically on Ztunnel we had already seen that it was communicating over port 15008. So that port, this guy listens to that and forwards the request to whoever is intended to. So that same port we need to give. So 15008, so port, and protocol, we can mention all protocols it is listening currently. Yeah, so once we deploy this, our request to eco server 1, it will go through now via basically this guy, Waypoint proxy, that we can verify as well in some time, not an issue. So let's go ahead and first deploy this. Sorry, what was the name? Waypoint. Sorry, my bad. Fine. So now this, now the linking, basically now the linking need to be done. So we have deployed it. So we need to tell the authorization policy to forward that request, like to who will be basically handling that L7 request. So for that, we need to update our authorization policy one time so that we can, so that it points to basically right pod, or basically right uh, workload who is handling that request basically. Okay, so for that, we just need to apply the request. Okay, so we need to know the name. Okay, so we need to know the name of the particular, like to whom that particular request need to be sent for the handling. So for that, we need to get the label. So let's go ahead and check. We just created eco server gateway, and let's go ahead and verify that. Okay, we created inside namespace ambient. Yeah, fine, perfect. Let's go ahead and check the label. That same label we need to apply there. kubectl get y ambient. Yes, so we have created this one. Let's describe this guy to get, or basically, okay, what are the things it is having? So it is accepted and ready. Yeah. So this we need to verify it is in ready state. After that, we should be able to use it. For that, what we need to give is waypoint proxy. We have given some name, this name that need to be mentioned. Basically, this label also will be applied automatically to the gateway or the waypoint proxy which it created. So, and we can verify that also. So we'll verify, not an issue. So here we need to give a label. So now we'll be changing that label and pointing towards the waypoint proxy. So for that Istio, we need to give istio.io as gateway name. So here we are seeing it's a gateway name. It means we can assume, or we can think these waypoint proxies as a gateway for the pods for which it is serving, or for the deployments for which the particular waypoint or workload for the particular waypoint is deployed, or basically the service account. So it's a gateway for that, and it all the request goes through this Waypoint proxy now onwards. And here we need to give that name. So, and this we can verify this match label also here when we did our describe. So here we should be able to see the label annotation label go server 1 minute, not this one, sorry. We need to check the pod basically. So let's go ahead and check pods. Here we can see we have waypoint. So when we created that gateway, this waypoint got created with the name of this. So let's go ahead and verify that label. kubectl describe pod ambient. So here we can see we should be seeing the same label what we applied. So here, even we can copy directly from here, and we can, to make sure we are not making any mistake in typo, we can apply that here. So now this request and will be handled at that waypoint proxy level. For to verify that L7, let's add our L7 related few rules basically. So two. So from we saw that one, and source we saw, and now we need to apply L7 related rules. So two operations, basically what all the operation we are allowing. Give method like what all the methods we are allowing. So that's the thing basically. So here, so if we give get, it means only get requests are allowed, and other than this, nothing will work, like put, delete, and all, it will not work. So let's go ahead and deploy this first. Verify it from the browser, verify it from the terminal, like from the other pod, which we have already into. Let's go ahead. kubectl. So we deployed our gateway like Waypoint proxy, and we have updated our authorization policy file basically to point to a new basically Waypoint proxy, and we have added the L7 related few operations here to test. So let's go ahead. Demo and demo authorization. Let's go and apply. Fine, it is working. So let's go ahead and test it here. It should work still from here because we are allowing this one to work. This guy is anyway, like we have not touched anything, so it should work. Now let's go to the terminal in which we were sending a request to another pod basically from here. So far, if we see, we were seeing this kind of request like host name, this kind of thing was coming, and server values. And when it was getting denied, we saw some terminated some request. We'll be seeing something here. So let's verify first two. It should work. Now coming to one. So we are seeing access denied now. Later we were seeing some different error. Now it is coming RBAC access denied. So this access denied request, now this is basically it's coming from our Waypoint proxy. So it means we can verify now the request for the service one, it's going through the Waypoint proxy, and there are RBAC policies who are applied, and now we are getting a different kind of error. Fine. Yeah, that's all we have covered for today's session. Almost everything which had to be covered. Let me just bring that. Just hold on a minute. Yes, we have already tested this one. We have, yeah. So we have covered all the points, whatever we had in the agenda, we covered it. And that's all for today. If you have any question at any point of time, please feel free to contact us at contact@imesh.ai. Thank you very much for your patience.